In this video, we're going to do questions with a new set operator. So much like the new logical operator videos, we can also do them for sets. So A symmetric difference B is the symmetric difference. So again, this is kind of like saying XOR. So I'm going to call it XOR. It's pretty much the same as it is in logic. So either X is in A, X, or X is in B. So it's exclusive. So the first one, I want to find the symmetric difference between these two sets, 2, 4, 6 and 2, 3, 4. So this is the set of all elements such that the element only appears in one of the sets. So we see 2 in both sets, we see 4 in both sets, but we only see 6 in the first set, and we only see 3 in the second set. Therefore, the symmetric difference is 6 and 3. So let's draw the Venn diagram for that. So I really just want the Venn diagram for a symmetric difference B, but let's plot the elements in there anyway. So 2 and 4 are common to both, 6 is in the first, 3 is in the second. So the symmetric difference looks like this. So it covers everything in A and B that is not in the intersection of A and B. So this, you can see, is the equivalent of A minus B union B minus A. So you can use this equivalent to say, okay, this is the same thing as A exclusive OR B, which is sometimes written as a triangle B. I find the triangle much harder to write and make it look good. Sometimes it doesn't stand out very well, so using this symmetric difference symbol does save me a lot of time when I'm looking at notes or looking at questions and trying to understand exactly what I'm talking about very quickly. Okay, so that's the first question. The second question, of course, is going to be a set law equivalence. So this is hard to show as set laws because we don't know anything about this. So we can define it in terms of complements and unions, but that could be tricky. So let's do a proof with letting X be a part of this. So we're just going to go in one direction. If you want to go from A backwards to A, exclusive or B, then feel free. You just reverse the steps. So we're going to say, okay, we're going to let X be an element of A difference B difference B. So what this means is that X is going to be an element of A difference B exclusive or X is going to be an element of B. So either X is in B or X is in A difference B. Okay, so we're going to have X is an element of A XOR X is an element of B XOR X is an element of B. So in this case, we could distribute and find some properties, but really we should take this by cases now. So let's assume that X isn't an element of B. Okay, so if X is an element of B, then this says that X is not going to be an element of A, and more importantly, X is not going to be an element of B. And of course, this is problematic because we're assuming that X is an element of B, but we see that if we say it is, then we're going to get that it's not. So if it's in here, then it can't be in A. So this would be a 1, but then that means that this has to be a 0 over here. Otherwise, the whole statement's not true. So we're going to have that X is in B and X is not in B. So that's a contradiction. So it can't be in B. But if we assume that X is in A, so if this is a 1, then X is in B can be a 0. So we know X is not going to be in B. And this whole thing satisfies. So to get this XOR to satisfy here, we need X to not be in B there. So this is consistent. So the only way this is going to be true is if x is an A. Therefore, this is going to be equivalent to just the set A. So that is another question with symmetric differences. I know I said differences for some of them there, but hopefully with context you know I'm talking about symmetric difference. It's just a mouthful to say when you're talking about the operator, so we're going to let that slide. Anything that can make explanations sound a little bit more concise without a bunch of words, they're probably for the best. So if you have any other questions, please leave them in the comments below and I'll answer them the best that I can.